In this recording, we're going to learn how to graph and confirm rational functions that have horizontal asymptotes. So let's first talk about the type of steps we're going to need to take in order to confirm some of these things algebraically. And then we'll make the graph and go ahead and do an example confirming these out. So these are the conditions that we're going to have to comply with. So first, we're going to confirm the end behavior asymptote. Now, it kind of depends on the form of the rational function what the end behavior asymptote is going to be, whether it's going to be the x-axis or some other horizontal line, or maybe not even a line at all. So the way we're going to define it is, before we said we had a rational function would be something of this form, f of x over g of x, right? But we're also going to state it as y equals some function of this form with a sub n, in other words, the coefficient of the leading term, x to the n power, so the degree of the polynomial in the numerator. And then in the denominator, we're going to say b sub m is the coefficient of the leading term of the polynomial in the denominator, and x to the m power, where m is the degree of the polynomial, the largest exponent of the denominator. Okay, so that's going to be useful actually. When you see this n less than or equal to m, that's what we're referring to. What's the degree of the numerator compared to the degree of the denominator? And that pretty much tells us what we need to know about the asymptote, the end behavior asymptote. So these are the three possibilities. So if n is less than m, bigger degree in the denominator, you're always going to have y equals 0, in other words, the x-axis, as the horizontal asymptote. Later in the course, when we learn a little bit about limits, we're going to be able to sort of show why this is the case. Okay, so if n and m are equal, in other words, maybe it's something like x squared in the numerator with a 3x squared, the denominator is like 4x squared or something like that, both the same degree, then the horizontal asymptote, it turns out, is just the quotient of those leading coefficients, a sub n divided by b sub m. Okay, third and final case. Okay, so if the numerator's degree happen to be like x cubed over something with just x squared or just even an x, you don't have a horizontal line as the asymptote. You have what's called a slant asymptote. And that could be a line that is a slope other than 0, or it could be a parabola or some other function. Okay? Second thing we're going to have to do, let's use a new color. Confirm the vertical asymptotes. We've already had a little experience with that. There could be more than one. And that's pretty easy to find. It's the zeros of the denominator. So we set the denominator equal to 0. And again, that's called infinite discontinuity. Okay, so we'll take care of those two things. Next, we're going to confirm the x-intercepts. There's no prescribed order to doing these confirmations, so don't stress out about, well, what if I forget this order in which I do it in? Just make sure you have all the parts, and you'll know them pretty well by the time we get to actually have to do it. The x-intercepts, if you remember on a graph, any old graph, the x-intercepts are where the zeros, where the y equals 0. Okay, so in other words, where the numerator equals 0, because that would make the whole fraction equal to 0. So the x-intercepts are the zeros of the numerator. That's pretty easy to do, right? Set the numerator equal to 0, solve by factoring. Okay. Next, we're going to confirm the y-intercept. So this is kind of like going in order. Confirm the end behavior asymptote, confirm the vertical asymptote. Confirm the x-intercepts, confirm the y-intercept. So it should be fairly systematic for you. Okay, so think about it again, a graph. Y-intercepts are where x equals 0. So you're just going to substitute in 0 for your x's and then solve. Okay, so the value of f of 0 if defined. So you may or may not actually have any y-intercepts. Finally, step 5. You're going to confirm the intermediate behavior. Okay, well, what's that? We did that before. It's the behavior of f between and beyond the x-intercepts and vertical asymptotes. Okay, now that we have laid out the steps for ourselves, let's proceed to do an example where we graph a rational function and confirm its behavior. I'll give you a chance to jot down this example. All right, so let's go through our steps. First, horizontal asymptote. Well, because the degree of the numerator is a 1 and the degree of the denominator is a 2, the n is less than the m, therefore our horizontal asymptote should be y equals 0. Okay, go ahead and feel free to write notes to yourself about what n means in this case. That's the degree of the numerator, and m means the degree of the denominator. Okay, next, let's find out the vertical asymptote. Again, that was our end behavior right there. So in other words, the end behavior means out at the extremes, the y values are going to get really close to 0. Let's talk about the vertical asymptote. Well, we want to work this out algebraically, so we're going to take our denominator and we're going to solve for when x equals 0. For when the denominator equals 0, I should say. What makes the denominator equal 0? So go ahead and do some factoring. All right, so that should be a plus right there. And therefore we have the values of 3 and negative 2. Okay, so we could peek at the table to see that, in fact, that is the case. We'll do that in a moment. Let's next talk about the x-intercept. Well, of course, the x-intercept is where the numerator equals 0. Supposed to be a minus. So that's where x equals 1. Okay. So that's the point. Remember, an intercept is a point. So 1, 0. Let me go back and box in. I want to be consistent. Let me box in my vertical asymptotes. I've highlighted all the things that we've accomplished so far. So we're expecting vertical asymptotes at those two places. Notice how we write our asymptotes as equations, okay, and our intercepts as points. I want to emphasize that. Intercepts are points, asymptotes are equations. All right, our y-intercept. So the y-intercept is the place where f of 0 is. So we want to substitute in a 0 for all our x's. So I think we can see that we have a negative 1 over a negative 6. So 1/6. So the y-intercept is the point 0, 1/6. I'm kind of reserving this space right in here for a sketch, if you're wondering what's going on with that space there. Finally, our intermediate behavior. Okay, so let's wait till we have our sketch of our graph to check out that intermediate behavior. So let's go to our graphing calculator. Let's enter that function. So we'll do a zoom 6 for a standard window there. We can tell that we do have our vertical asymptotes where we thought they would be. Looks like at -2 and +3. It does look like we have a horizontal asymptote of the the x-axis, or the line y equals 0. Furthermore, it looks like our y-intercept is just above the origin, so around 0, 1/6. It does appear like we have an x-intercept at x equals 1, 1, 0. So let's confirm a couple things with the table. With the table, we can see we have an error at 3, and do we also have an error at -2? We do. And we also want to check that we have the point 1, 0 on the table, which we do. So we can confirm all those things. Now we can just make a sketch based on that on our notebook paper. So use a ruler if you have one. So I'm going to zoom in a little bit when I make this sketch. I won't make it quite as far out in the x directions. All right, at this point I've got my axes laid out. I'm going to draw a dotted line at x equals 3 and x equals -2. Okay, so go ahead and label both those vertical asymptotes. We've got the y equals 0 is our horizontal asymptote. Okay, that's already established as the x-axis. We know we're going to hit this point right here. So we'll label that point 1, 0. And then we have another asymptote right there. Another intercept right there along the y-axis. So we're going to draw this sketch. And now we're finally ready to state the intermediate behavior, just talking about what's happening near our vertical asymptotes on either side of them. So what we're going to say is, as x approaches -2 from the left, what's happening to f of x? And then as x approaches -2 from the right, and I indicate that with a little plus superscript on the -2, what's happening to f of x? Okay, so hopefully you realize from the left, the y values of the function are getting smaller. They're approaching -infinity. And the opposite is true, although it won't always be true. Don't assume that it's always the opposite. The opposite is true as we're going from the right side approaching the asymptote of -2. F of x approaches infinity. Okay, so we can state the intermediate behavior around the other vertical asymptote as well, and it happens to be very similar. Thanks for watching.